All right, let's take a look at the next example. This one, we've got, again, the first four non-zero terms and the general term of the Taylor series about x equals 0. So again, since it's about x equals 0, it's really also a Maclaurin series. Derivatives of all orders, the derivative exists everywhere. This one wouldn't be too bad if we did it the traditional way, because we'd have to just keep using the chain rule over and over again. The derivative e, that e part stays the same, so that wouldn't be too difficult. But it's even easier if we remember the e to the x one. So look at what we've got here. So remember e to the x, the pattern here, it's not alternating, they're all positive, and it's like having sine and cosine together, so you have all the terms. So it'd be 1 plus x to the first plus x to the second over 2 factorial plus x to the third over 3 factorial, and then so on. And then the formula for it is just x to the n over n factorial. So that's e to the x, but we have to modify this in two ways. Notice instead of x, we've got negative x over 2 in place of the x, so we'll have to replace all the x's with that. And we've got a 5 on the outside multiplied by for those two things. So we'll have 5 times, I'll put a big old parentheses there. And then if we substitute in negative x over 2 for all the x's, well, the 1's not going to change. But instead of x, that'll be negative x over 2 plus negative x over 2 squared over 2 factorial plus negative x over 2 cubed over 3 factorial plus dot 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 plus, we'll substitute in here as well, negative x over 2 cubed over, sorry, not cubed, to the n over n factorial plus dot dot dot. And again, that whole thing is multiplied by 5. Let's first simplify inside the parentheses, and then we'll distribute the 5 at the end. So this first one is just going to be 1. That doesn't change. And this is going to be negative x over 2. This is going to be, well, negative squared. Negative 1 squared, that's going to make it stay positive. And then just think, if you square this 1/2, we'll have x squared, obviously, on there. But let's see what it's over here. If you square that, that's going to be 1/4, right? But you're dividing by 2 factorial, which is 2. 1/4 divided by 2, that's 1/8. So you'd have x squared over 8. This is negative 1 cubed. That's going to make this one negative. 2 cubed is 8, so that's 1/8. Divided by 3 factorial, and 3 factorial is 3 times 2 times 1. So 1/8 divided by 6, that's like 1/8 times 1/6. So that'll give you x cubed from right here over 8 times 6 is 48. First four non-zero terms, that's going to give us those. We'll just multiply by 5 plus, here, distribute that out. We've got a few different things. We'll have, easier to write in this case, we've got negative 1 to the n. We've got x to the n. And the denominator, we've got 2 to the n. Okay. And then divided by n factorial, that's like multiplying by 1 over n factorial, so that n factorial just stays in the denominator. And then we're multiplying these all by 5. So this becomes 5 minus 5x over 2 plus 5x squared over 8. Oops. Minus 5x cubed over 48. There's our first four non-zero terms. Plus, well, it just multiplied these all by 5, so it'll do the same thing with our general term. So it's just going to be 5. Negative 1 to the n, x to the n, over 2 to the n, n factorial. Notice you can't distribute the 5 with the negative 1, negative 5 to the n, because then that would mean you'd be raising 5 to the nth power, so these wouldn't stay 5, it'd be 5, 25, 125, which doesn't happen. So it just has to stay separate like that. So there would be our first four non-zero terms and the general term for that Taylor series or Maclaurin series. All right, let's take a look at the next one. So sometimes they may not use one of those four that you expect to memorize, and instead they'll give you one which they don't expect you to memorize, but they'll tell you what it is. Sometimes they'll write in summation notation. Sometimes they say the Maclaurin series for natural log of 1 plus x is x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4 plus, and they give you the general term right here. So they're giving you the whole thing because they don't expect you to have natural log of 1 plus x memorized. And then they're saying f of x is natural log of 1 plus x to the fourth. Very similar to this, except notice one key difference. X to the fourth is in place of x. So again, it says write the first four non-zero terms and the general term of the Taylor series about x equals 0, which again is a Maclaurin series, really. So just like the other ones, we have to modify it. Wherever there's an x, it gets replaced by x to the fourth. So we'll have x to the fourth in place of that x, minus x to the fourth squared in place of this x, divided by 2, plus x to the fourth cubed over 3, minus x to the fourth over 4, plus, and then negative 1 to the n plus 1, x to the fourth to the n over n. And then we can just simplify that a little bit. So we get x to the fourth minus x to the eighth over 2, plus x to the 12th over 3, minus x to the 16th over 4. There's our first four non-zero terms. Plus negative 1 to the n plus 1, x to the 4n over n. So you modify it in the same way. It's just they give you one, you're modifying instead of having to use one you've memorized. Again, if you want to check to see if it works, you could try plugging in 0, but then notice divided by n, plugging in 0, that's not going to work, is it? So this is one where you actually start 1. If you plug in 1, notice it'll be negative 1 to the second, which is positive. First term is positive. Plug in 1 there, that's x to the fourth, divided by 1. Substitute in 2, you get negative 1 to the third, which is negative, so the second term is negative. Plug in 2 there, that's x to the eighth. 2 there, that's 2. So you can see that form of general, for the general term, does work. Okay. Now let's take a look at if we are given one where they tell you the sum, or basically asking you for the sum of this series, is which of the following. Okay. This is another one where they really expect you to have those first four memorized to figure this out, to know which one it goes with. You don't really have time on the AP test to derive each of these options here. So look at what we have. Well, it's alternating, right? And you can see the exponents are even. Notice that this fits the pattern for sine, sorry, not sine. The one function that's even is cosine. Sine is an odd function, right? So this is the pattern for cosine x. But notice we don't see the x because the x would usually be right here where all the e's are. So that's your clue that it's just cosine of e. It fits the pattern for cosine. Just e being plugged in for all the x's. That's it. If it was sine, you'd see the alternating pattern with the odd exponents. If it was e to the e, you'd see it all positive, not alternating, with no missing terms. And if it was 1 over 1 minus e, you would see, well, this one actually would diverge because e is not between negative 1 and 1. The common ratio would have to be between negative 1 and 1 to fit the pattern. So in that case, if this fit the pattern for 1 over 1 minus x, it would actually be non-existent if e was plugged in, because e is not about 2.7, it's not between negative 1 and 1. All right, and that concludes the notes for AP Calculus on the topic of the common Maclaurin series.